Good afternoon, my YouTube viewers. It is Crystal here. I wanted to make another video for you. This video is going to be a code review, but before I do the code review, I need to carry out an explanation so you'll know exactly what it is that I am talking about. So, in my last code review, I was talking about Ohm's law, and I gave you 12 formulas that you can use to calculate Ohm's law and Watt's law to find out the values for voltage, amps, resistance, and power. Well, in this particular video, what I'm going to do is I'm going to tell you how to calculate resistance in a series circuit, a parallel circuit, and a complex circuit. And we're going to do a code review as well. But before I can do the code review, I have to go over to you how to calculate the resistance. So if you were going to do it on your calculator. So we're going to use Python to calculate the resistance, but if you had a calculator, you could use a calculator. But the neat thing about using Python is you can take these formulas and you can convert it into a function, and then you can put the function into a library, and you can call the function up whenever you want to call the function up. So that's the neat thing about doing calculating the resistance in Python. And if you're going to be calculating a lot of resistances and working on a lot of circuits, then it would be in your best interest to make functions to calculate these values, and then put the functions in a library, and then in your library you can call up the functions as you need them. And I personally have never made a library, but there's something called PyPy. I think it's PyPy, but it's definitely PyPy. And you can use that to create your own library. And then when you create your own library, it goes online, it goes on the public domain. But the problem with using PyPy is a lot of people put libraries on it, but then those libraries are not maintained. So me personally, I prefer to use the standard libraries such as Pandas, NumPy, Matplotlib, Seedborn, and those types of standard libraries that you know, and sklearn, that you know are going to be maintained. But if you're going to make your own library and maintain it and put it on PyPy, then there's nothing wrong with that. Now, I personally have never created my own library, but I just might do it at some point. I may actually create a library and put it on PyPy just to show you how to do it. So just watch this space. You never know, one day I may do it. So now that I have discussed with you the fact that we're going to do a code review, but before I do the code review, I have to explain to you how it's done. What we'll do is we'll go ahead and get on with the explanation. So the first thing we're going to do is show you how to calculate the resistance of a simple circuit. So this is your simple circuit. So the way you calculate the resistance of a simple circuit is you add the resistances together. So RT, that's R total, equals R1 plus R2. So if you've got two resistors, one of 10 ohms and one of 20 ohms, that's going to be the equivalent of a 30 ohm resistance. So that's your simple circuit. And so now what we're going to do is we're going to talk about calculating the resistance of a parallel circuit. So this resistance that we just discussed here, this is series. This is the resistance of a series circuit. And so a 10 ohm resistance with a 20 ohm resistance is going to give you a total of 30 ohms. And now what we're going to do is we're going to calculate the resistance of a parallel circuit. And so the resistance of a parallel circuit is RT equals 1 over equals 1 over R1 plus 1 over R2, I believe. Let me see. So let's see, I believe it's 1 over R1 plus 1 over R2. Yeah, that's it. It gives you the formula there. And basically, the total resistance is going to be less than the lowest resistance. So if you have one resistor over it that's 10 ohms and another resistor in parallel that's 10 ohms, it's going to give you a 5 ohm resistance, because RT equals 1 over R1 plus 1 over R2 equals 1/10 plus 1/10 equals 2/10 equals 10 over 2 equals 5. So 5 is going to be less than the lowest resistance. So it does, I mean, if you're good at math, you could probably whip it up in no time at all. But if you've got a really large circuit to calculate the resistance on, then it might be a bit problematic, and you might actually want to do it using Python. So now what we do is we have another circuit that's 3 resistors in parallel. You've got 4 ohms, 6 ohms, and 8 ohms. So you already know that the lowest resistance, the total resistance, is going to be lower than the lowest resistance. So the lowest resistance is 4 ohms. So you know that the total resistance is going to be less than 4 ohms. So resistance equals 1 over R1 plus 1 over R2 plus 1 over R3. To the negative first power. So it equals 1/4 plus 1/6 plus 1/8, I believe, to the negative 1 power. So here it tells you how to do it. And the total resistance is 1.846 ohms. And you can see 1.846 ohms is less than the lowest resistance in the bundle. So when you start getting into series and parallel resistances, you can do it on a calculator, but if you can write a formula to do it, then that's going to be better. And now what we have is we have a complex circuit. And what a complex circuit is you've got resistors in series and resistors in parallel. So what you have to do is you have to take the resistors in parallel and convert that to a series resistor. So you've got two 20 ohm resistors in this parallel circuit. So you know that the lowest resistance is, the total resistance is going to be less than the lowest resistance. So you know that the total resistance is going to be less than 20. And so two 20 ohm resistors in parallel equals a 10 ohm resistor. So basically what you're doing is you're taking this parallel circuit and you're converting it to a series circuit. So now we've got a 15 ohm resistance that always was in series, and you've got this 10 ohm resistance that you converted to series, and so now you have a total resistance of 25 ohms. So we've got another circuit. So you've got a 40 ohm resistor, a 40 ohm resistor, and a 20 ohm resistor in parallel. So you know that your lowest resistance is going to be less than 20 ohms, and so you're going to calculate that. And so what you're going to do is you've got a 5 ohm resistor and a 15 ohm resistor and a 30 ohm resistor, and you've got this parallel circuit that you have converted to a series resistance. And so basically what you do is, after you have converted this parallel circuit to a series resistance, then you calculate the resistance as if it was a series. So And so we've got another circuit here as well, and they're saying the total resistance is 60 ohms, and we're saying that 5 plus 15 plus 30 plus 10. So 5 plus 15 plus 30 plus 10. So they're saying that that resistive circuit, which I haven't got a calculator on me to calculate it, is a total of 10 ohms. So that entire resistive circuit is going to give you 60 ohms. And then so we've got a parallel circuit and a series circuit. So you got a 10 ohm series, and then you got a 30 ohm parallel and a 20 ohm parallel. So what they're trying to say here in this complex circuit is you take the 10 ohms and then you add it to the 20 ohms to make it 30 ohms. So now you have two 30 ohm resistors in parallel, which will give you a total resistance of 15. So that's another complex circuit that you can look at. And then they give you some more insight into how to work on that. So this is one particular complex circuit where you have a 60 ohm and a 20 ohm in parallel, and a 30 ohm and a 10 ohm in parallel. So what they're saying now is 20 plus 10 plus 30 is 60. So they're saying a 60 ohm and a 60 ohm in a 60 ohm resistor and a 60 ohm resistor in parallel is going to give you a total resistance of 30, and then plus 10 here, and then plus 10 here. So that's going to give you a 60 ohm resistance. So that's going to give you a total resistance of 60 ohms in that circuit. So we've got another one, and we've got 10 ohms and 20 ohms and 30 ohms. So they're saying that's a total of 60 ohms, which I believe is what I said up here. So it does get quite complex, and these are simple circuits that we're talking about. But whenever you're talking about simple circuits, you take lots of simple circuits to make a complex circuit. So you have right here, you have a more complex circuit, which I'm not even going to do because I think that I have already explained to you the fundamentals of calculating the resistance in a series circuit, a parallel circuit, and a complex circuit. But what you do is you take lots of simple circuits and you combine them together to make one complex circuit. And so this is just give you some more information about how to do this. And they're saying that the last one that I didn't go over had a total resistance of 100 ohms for 30, 20, and 50. And so this entire circuit here has a total resistance of 100 ohms. So that's just something to look into. I'm not really here to discuss electronics with you that much. I'm here really to do a code review. But what I had to do is, in order for you to understand the code review, you need to know a little bit about electronics. And that's why I've had to go over this web page to explain the electronics to you. So now that we've gone over the fundamental electronics of how to calculate resistance in a series circuit, a parallel circuit, and a complex circuit, now what we'll do is we'll actually do our code review. So what I explained to you how to do in the previous website, you could easily do that with a calculator. But the problem with a calculator is you have to keep calculating it over and over and over again. But if you write a computer program to actually calculate the values for you, then you don't have to keep calculating it. And also, you have a margin of error. Every time you use a calculator, you have a margin of error. And that's why when you're using a calculator, you always have to check your work. So you might calculate it the first time, and then you set and calculate it the second time to make sure that the two values are the same. And if the two values are not the same, then you have to start all over again. So that's the bad thing about using a calculator, is if you check your work. But when you write a computer program, you check your work on the computer program. But when you know that the computer program is working properly, you just put the values in there and it does it for you automatically. So now that we have explained that, then we're going to go ahead and do the code review, which is what I wanted to do. So the first thing we're going to do is we're going to calculate the code review of a series circuit. So this series circuit has 3 resistors in it, R1, R2, R3, at 30, 40, and 50 ohms. So we've created a function called calc resistic series and accepts R1, R2, R3 as the input. So R tot equals R1 plus R2 plus R3, and then you return R tot. And that is your function. So you print total resistance, and then you call up the function calc resistance series, and you take as input R1, R2, R3, and you have a total resistance of 120. So the next thing we're going to do is we're going to calculate the resistance of a parallel circuit, and that's what we've done in the previous website. So again, you've got 3 resistors in parallel, R1, R2, R3, 30, 40, and 50. And you know that the total resistance is going to be lower than the lowest resistance. So you define your function of def calc resistance parallel. You take as input R1, R2, R3, and then you say R underscore reciprocal equals 1 over R1 plus 1 over R2 plus 1 over R3. And then you say R tot equals 1 over R reciprocal, and then you return your R tot. And then what we do is we print total resistance equals calc resistance in parallel as R1, R2, and R3, and your total resistance is 12.7. But what I want to do here is I just want to clarify something. It should be total resistance in ohms. So that should be total resistance in ohms. Okay, so now what we're going to do is we're going to calculate something called the product over the sum. So the product is going to, and you can use this formula when you have 2 resistors in parallel. So when you have product over the sum, it's R1 times R2 over R1 plus R2. So we've got 2 resistors, R1 and R2, which is 50 and 50. So these resistors are going to be in parallel, so you know that the total resistance is going to be less than the lowest resistance. So the total resistance is going to be less than 50. So we create our function of def prod over sum, takes R1 and R2 as your input, and R tot equals R1 times R2 over R1 plus R2, and you return R tot, and then you print total resistance in ohms, product over sum, R1, R2, and it gives you a total resistance of 25. And you say calculate resistance with more than 2 parallel resistors. So we've got 3 resistors, R1, R2, R3, and it's def calc resist parallel, and it takes as its input R1, R2, R3. R tot equals 1 over R1 plus 1 over R2 plus 1 over R3, and then you return R tot. and you say total resistance in ohms is calc resistance parallel. You're taking R1, R2, R3 as the input, and it gives you a 27.27 ohms. And you notice that the lowest resistance in the bunch is 50, so your total resistance is going to be less than the lowest resistance. So now what we're going to do is we're going to take a circuit that's going to have 2 parallel and 2 series resistors. So number one, when you have a complex circuit of parallel and series resistors, what you have to do is you have to take the parallel resistors and you have to convert those to series. So we've got the RP1 and RP2 are the 2 parallel resistors of 30 ohms each. So the total resistance of RP1 and RP2 of 30 ohms each is going to be less than the lowest resistance of 30. So I'm just going to take a wild guess and say it's going to be 15. And then now we take our 2 resistors of series, R1 and R2, RS1 and RS2, that's 10, 20, so that's 30, and then the 15 is going to be 45. So I've just calculated it myself to say that it is 45 ohms. But what we'll do is we'll go ahead and create a formula for that anyway. Calc resistance combine, RP1, RP2, RS1, RS2, R parallel equals 1 over RP1 plus 1 over RP2, and R tot equals RS1 plus RS2 plus R parallel, and you return R tot, and it gives you a total of 45 ohms. So those are the formulas that we have come up to give you calculating total resistance in series, parallel, and combined. So, and then now what we've done is we've done that in Python. So now you know how to do that in Python. So if you have a circuit and you don't want to use a calculator, you would like to write a program to calculate the resistance in the circuit. Well, you've got all of the formulas that you need to actually calculate the resistance in a circuit. And I will say that they do have electronic breadboards, which I found that out while I was doing my studies. And if you want to pursue electronics and make electronics and combine electronics with computing, there are electronic breadboards that you can go onto and use to create your own circuits. I personally never created my own circuits. I was a technician when I was in the military, but if you're interested in creating your own circuits, you can use a breadboard to do that. And then when you are creating your own circuits, you're going to have to calculate the resistances and other values to make sure that the circuit works. So that's all the formulas that we have for calculating resistances in series, parallel, and combined. So I'm going to go ahead and finish this video. I would like to say that I would like to thank all of my subscribers for supporting this channel. If you like my video, then please like, subscribe, and share. And I look forward to making more videos for you in the future. So thank you so much for watching.